Hello students, today I'll be discussing with you the question answers of chapter number 5 of your curiosity book. So let us start. So here is your first question. The question says, some lengths are given in column 1 of table 5.5. So here's your table 5.5. Some units are given in column 2. You can see in column 2 they have given some units. You have to match the length with the units suitable for measuring those lengths. Okay, so let us first understand the question. Thing says distance between Delhi and Lucknow. So how are you going to measure the distance between Delhi and Lucknow? So remember students, whenever you have to measure large distances, okay, large distances like distance between two cities, like in this case we have to measure the distance between Delhi and Lucknow, distance between two cities, then we use a bigger unit for the measurement. So if you see over here, the biggest of all is kilometer. So to measure distance between Delhi and Lucknow, we will use the unit kilometer. The second one says thickness of a coin. Now, when you look at a coin, you all must have seen a coin. So if you look at a coin, you see the thickness of coin is very less, and measuring the thickness of a coin has to be done using the smallest unit. Okay, so here if you see in the table given in the column 2, the smallest unit is millimeter. So we are going to measure the thickness of a coin using millimeter. All right. Same way, length of an eraser. So how does an eraser look? Somewhat like this. Yeah. Okay. This is a one-dimensional view of an eraser. Like this you can see. So if you want to measure the length of an eraser, you can easily use a scale which is there in your pencil box. And the markings on the scale is given in centimeter. All right. So length of an eraser can be measured using the unit centimeter. Finally, the length of the school ground. Now, length of the school ground is not as large as the distance between Delhi and Lucknow, or in any distance between any cities. So, you can measure the length of a school ground using the unit meter. So, like if you want to measure for example, if you have done my lecture, I told you that Deepa went to the tailor's shop, the shopkeeper's shop. The shopkeeper was measuring a piece of cloth using a meter scale. Okay, right? So, if you want to measure a piece of cloth, if you want to measure the length of a school ground, all these things can be measured using the unit meter. All right? Now, let us come to the second question. The second question says, read the following statements and mark true and false. So the first one is, the motion of a car moving on a straight road is an example of linear motion. Now students, if you see my lecture, I have discussed with you 3 types of motion. What are the 3 types of motion I have discussed with you? Just a second. So the 3 types of motion I have discussed with you. One is linear motion, one is oscillatory motion, and one is circular motion. All right. So these are the 3 types of motion we have discussed in our lecture. Now, when we talk about linear motion is a motion that takes place in a straight line. Okay. So you have to look for the keyword straight. So here you see you have a keyword straight over here. So the motion of a car moving on a straight road is an example of linear motion. True. Now the second one. Any object which is changing its position with respect to a reference point with time is said to be in motion. Now we also discussed 2 terms, that is motion and rest. Now, whenever we talk about any one of these terms, how do we define them? We tell them that, what do we say? That whenever an object is changing its position with respect to its immediate surrounding or with respect to a reference point, then it is said to be in motion. And when an object does not change its position with respect to its immediate surrounding or with respect to a reference point, then it is said to be at rest. So here you see it is changing its position with respect to a reference point. So clearly it is said to be in motion. So this is true. Now, the third one, 1 kilometer is 100 centimeter, false. Okay, so now these relationship students, you have to learn 1 kilometer is equals to 1,000 meter. All right. Same way, if we say 1 meter is 100 centimeter. All right. Same way, 1 meter is 1,000 millimeter. Okay, so there are certain relationships which you will have to learn. So here, if the teacher asks you to correct the statement, you can clearly say 1 kilometer is not 100 centimeter. 1 meter is 100 centimeter. All right. Okay, now coming to the third question. The third question says, which of the following is not a standard unit of measuring length? Now, what do you mean by standard unit? A standard unit is a unit if you use it usually when we have certain measuring tools like your measuring tape. Okay, we have a flexible measuring tape, we have a metal measuring tape. All right, so when we use these measuring tools, we get a standard unit of measurement. Okay, and which, here the question says which is not a standard unit. So which one is not a standard unit? Handspan is the correct answer, because handspan, as I discussed in the class, we all have different size of our hands. So if we are going to measure anything using our hand, each of us will get a different reading. So therefore this is not a standard unit of measuring length. All right. Number 4. Search for different scales or measuring tapes at your home and school. Find out smallest value that can be measured using each of these scales and record your observations in a tabular form. So this is something you should be doing, but still I'll be helping you out a little bit. So what you need to do is you have to find different scales or measuring tapes around your house and school. So suppose you have at your home a measuring tape, you can say the flexible measuring tape or the metal measuring tape you will get, or the you also get the you must be having with you a wooden ruler. Okay, so I'm just giving few examples, you can take any of them. Okay, you can get a ruler, normal school ruler, or the ruler of your in your geometry box. Okay, you can have a tailor's measuring tape, which is also called a flexible measuring tape. All right, flexible measuring tape. Okay, and what else we can have? We can have a home measuring tape. All right, at homes we have certain measuring tape, so you can have that also. So you can just get 3 or 4 like that, and what you will see, all of them has a reading. Okay, either it is in centimeter, they're in inches, they're in meters. But if you see the smallest, as they are asking us to find the smallest value, all of them will have it in millimeter. All right, so millimeter is the smallest, all of them will be have. All right, so this is your task, you are going to do it. It's not that I have done over here so your work ends. No, you're still going to find the rulers and you're going to make this in the form of a table and write down your observations. All right, physics is all about application. Teachers can tell you the answer, can give you the explanations, but until unless you apply yourself, you will not be able to improve. All right, so now question number 5. Suppose the distance between your school and home is 1.5 kilometer. Express it in meters. So just now we discussed how can you convert kilometer to meter. 1 kilometer is 1,000 meter. So if 1 kilometer is 1,000 meter, 1.5 kilometer will be equal to 1.5 into 1,000. So that's going to give you 1,500 meters. All right. So the answer over here is 1,500 meter. Correct? All right. Now let us come to the next question. Question number 6. Take a tumbler or a bottle, measure the length of the curved part of the base of the glass or bottle and record it. Now, how are you going to measure the base or the curved part? Remember, I told you to measure the distance or length which of the curved path of any surface or any object. What you need to do is either you take a flexible tape, flexible measuring tape. This is one way you can do it. The other way to do it, take a string at your home. It has to be easily available, a string or a thread. Take that and just suppose you are measuring the base of a bottle. So just take that string around the base of the bottle or the object you are measuring, and then take the length of the string to a meter scale or the ruler which you have at your home. Sorry for the bad drawing, guys. So the string suppose measure up to here. So whatever marking is over there, you will get the answer. All right. Is that clear to all of you, or do I need to explain it more? Just remember, what you need to do is you have to measure the length of the curved path of the base of the tumbler or bottle using a flexible measuring tape or a string, and then record the value in centimeter or millimeter as per the tape. All right. Will be done? Just let me know if you face any problem. I'll discuss with you. Okay. In the comment section, you just need to mention if any issue you are facing at all. Number 7. Measure the height of your friend and express it in meters, centimeters, and millimeters. Very simple. Suppose if we take an average height of a person, it is like around 1.6, 1.5, okay, meters. Suppose I'm taking 1.5 meters, 1.7. Just take an average, okay? I'm taking an average of 1.5 centimeters. So meters. So if 1.5 meters, then you have to convert it to centimeters. So how do you convert it to centimeters? Remember 1.5. Remember I just told 1 meter is 100 centimeter. Okay. So 1.5 meter is equals to 1.5 into 100. That is going to give you 150 centimeter. So answer will be 150 centimeter over here. Same way you have to convert it to millimeters. How are you going to convert it to millimeters? Again, I'm repeating, 1 meter is 1000 millimeter. So 1.5 meter is 1.5 into 1000 millimeter. So that is going to give you 1500 millimeter. So the correct answer for this question is 1500 millimeter. All right. Now, number 8. Number 8, in this question, you are being given a coin. You have to estimate how many coins are required to be placed one after the other lengthwise without leaving any gap between them to cover the whole length of the chosen side of the notebook. Verify your estimate by measuring the same size of the notebook and the size of the coin using a 15 centimeter scale. All right. So it is very simple. How are you going to do? Just you have to take a notebook, and suppose the length of the notebook is around, let us take maybe 30 centimeter. Okay, you can just take a notebook and just measure the length. Not necessarily you have to take 30 centimeter over here. You can take any length notebook and write down your own observations. Okay. Now take a coin, whichever coin you are taking. Now you have to measure the size of the coin. Suppose it is like 2.5 centimeter, the size of the coin. Now, what you need to estimate is the number of coins needed to equate the length. Okay, so how are we going to find it? 30 divided by 2.5. Then you will get the number of coins. How many coins will be needed? 12 coins. All right, so the correct answer over here, there's no correct answer over here. Obviously, you will write your own observation, but as per the measurements we have taken, we will be needing 12 points. Please do it and mention in the comment section what is your answer. Okay. Now, question number 9. Give two examples each for linear, circular, and oscillatory motion. Okay, question number 9. Linear, just a second. Yeah. So linear motion, as I told you, motion in a straight line. So can you give any two examples of linear motion, motion in a straight line? Just one we did, car moving on a straight road, car moving on a straight road. What else can you say about a linear motion? We can also say a stone falling freely, stone falling down freely. We can write that. A person walking on a straight road, we can write that. A cyclist cycling on a straight road, we can write that. Okay, just stone falling freely. So a stone falling freely means this is a stone, it is falling down freely. So it is moving in a straight line. So it's also an example of linear motion. Now for circular motion, what are the examples? You can say merry-go-round is circular motion. Merry-go-round is a circular motion. What else we can say? The motion of a ceiling fan, right? Motion of a fan. It's better if you write ceiling fan. All right. Now coming to oscillatory motion. Oscillatory motion, you can very simple pendulum. Oscillatory, I'm writing over here. Oscillatory. Okay. Pendulum of a clock. You know the pendulum of a clock? How does it goes ding dong, right? So the pendulum of a clock. And another one can be the motion of a swing. Both of these I have discussed in the lecture. Motion of a swing. So these are two examples of oscillatory motion, right? Number 9 done. Number 10, observe different objects around you. It is easier to express the length of some objects in millimeter, some in centimeter, and some in meter. Now you have to make a list of 3 objects in each category and enter them in table 5.6. So here we have a table. We have to take 3 objects which is suitable for measuring in millimeters, then 3 for centimeter and 3 for meter. So you are going to do it for me, right? 1, 2, 3. I can give you one example of each. Suppose you have to measure the thickness of a coin. So that you can do with the help of millimeter, thickness of a coin. Now the remaining 2, I want you to write down in the comment section so that you can apply. If I tell you everything, that won't be good. Now, for centimeter, you can say the length of a pen, right? Length of an eraser. We just discussed, right? Length of a pen, length of an eraser. Again, one I'm leaving it for you all. Let me see if you get the right answer. Now coming to meters. Okay, as I told you, length of a field, length of a field, length of a piece of cloth, piece of cloth. Okay, so the third one again is your task. You're going to do it. It's very easy. You can easily tell me the answers, and if you are facing problem, you don't know the answers, you can also mention it in the comment section. I will give you the answers for all of them. All right. Now coming to question number 11. Question number 11 says, a roller coaster track is made in shape shown in 5.19. Okay, so a ball starts from the point A and escapes through point F. Identify the types of motion of the ball on the roller coaster corresponding portions of the track. So at A, at B, at C, E, D, F, these are the points. What will be the motion of these balls when they are crossing these points? Okay, so let us find out. Now, if you see, the ball is going from A to B. It is in a straight line from A to B, right? So if it is in a straight line from A to B, it is linear motion. Now, from B to C is, you can see, a bit curved. Okay, so B to C, you can say curved or circular motion. Now, when you see C to D is also curved, right? So, C to D, if you say, is also circular motion. C to D, circular motion. I'm not writing it again. All right. Now, from, if you see, D to E is also circular motion. Okay. So, D to E. Acha, if you take parts, you can also say that these are curved motion. But yeah, I would like to say it as a circular motion. So basically, if you see that the path from B onwards, from B to E, is completely a circular motion. So you can write them down as B to E circular motion. Instead of breaking it into so many, we can simply write starting from B, ending till E, it is circular motion. Okay. Now from E to F, again it is in a straight line. So E to F is a linear motion again. All right. So think and apply. Observe, think, apply. Question number 12. Question number 12 says, Tasneem wants to make a meter scale by herself. She considers the following materials for it: plywood, paper, cloth, stretchable rubber, and steel. Which of these should she not use and why? Okay, now she cannot use anything which is stretchable, right? Because if she use anything which is stretchable, then that will not give us the correct reading. So that will not be a good measuring tool. So out of these, only one thing that is stretchable is stretchable rubber. So she should not use the stretchable rubber. It is not suitable for making measuring scale because it can stretch and deform easily. Because it can stretch and deform easily. All right. So a meter scale needs to be rigid and not stretchable. Okay, non-stretchable, to ensure that the measurements are consistent and reliable. All right. So now question number 13, which is our last question. Think and design and develop a card game on conversion of unit of length to play with your friends. So this card game, I want you all to think yourself. And if you're facing any problem, what are you going to do? You are mentioning it in the comment section. And after you mention your issues in the comment section, I'm going to solve it for you. Okay? So that's all for today. I hope you enjoyed learning. I hope you understood the explanations I gave against each answer. If you have any problem, feel free to put it down in the comment section. And if you need any help with anything, please mention it so that I can take it forward. Thank you all.